Hey guys, we are on to experiment 8, and this is actually my second time trying to record this, and the first time I got a little concerned a few minutes in because I started to smell something that I thought was kind of odd, like electrical burning or something. Turns out the AC adapter that we use for this kit, it kind of has some sort of weird like gassing smell. I wouldn't say it's necessarily, it's like a Voc. Let me turn this off for a sec. And we'll kind of pull this guy out for a minute. So this is the guy I'm talking about. He's still obviously got some sort of capacitor or something in here that's holding on to a little bit of a charge. But I was kind of feeling him, and the wire's fine. The wire doesn't feel overheated or anything. It's not like I'm drawing a crap ton of current. This is I guess this is just kind of I would say this is warm, and it just stinks a little bit, but I guess what I did is I went around my house and kind of put my hands on other AC adapters, and for the most part they all seem to sort of run a little warm. Not quite as warm as this particular one, but I think that's just the nature of converting the alternating current into direct current. There's like a lot of heat dissipation. There's probably some sort of heat sink in here. If I didn't really need this part right now, I'd probably take it apart and take a gander, but yeah, so they can generate a slight odor that might cause concern. So be warned if you know, you're doing some experiments and you smell something. I mean, always listen to your nose for sure. But for now, I think this guy's fine, so I'm going to continue with the experiment. And hopefully all will go well. So, experiment 8 was quite a interesting challenge. I thought it would be, hey, this is, you know, just add an extra part to the board and we're done. Turns out, adding that extra part, the capacitor, was not physically difficult. However, the reasons for why it is here are a little bit confusing. So I will do my best. And you'll notice that the switch is kind of relocated. I've reoriented a few things. Ground comes from here now instead of over here. Power comes from here now instead of over here for powering the coil. And the switch now controls powering the well, really connecting to the pole of the you know, the latching area, and it no longer controls direct powering of the coil. So what happens is, when the power flows through the switch, through this pole and out, one of the circuits just, you know, it basically has a fork right here, right? So one goes through the LED, through the resistor, and boom, this light would turn on. The other part would come and power the coil, which would push the latch away, and if the latch is pushed away, all of a sudden two things happen. We are now connecting the power to the upper latch through the LED, and we are also essentially dropping the power from the coil at the same time. So when the power that's running through the coil gets interrupted, the latch that was pushed up this way falls back down, and you end up with this super fast latch up, latch down, latch up, latch down, and it just goes, it would flicker very fast and essentially burn this relay out. And so the reason to have the capacitor here, you'll notice it is supplying the power and ground to the coil of the relay as well. It's kind of acting as a you know, a little mini battery charge, as a backup per se, like a you know, was it a UPS, or yeah, well, not the shipping company, but the yeah, the power bar, you know, components that you'd use to, you know, keep your computers running. Or is that USP? I don't remember. Anyways, The capacitor acts as kind of a backup battery that can last about a second. And so when the latch gets pushed up, that power supply that was powering the coil gets interrupted. However, then the capacitor takes over and starts offering up its charge to the coil, and it runs dry in about a second. So then the latch falls back down after this guy is tapped out. And when the latch falls back down, assuming the button is still held down, it charges back up and you get this circle. So this guy's here to kind of stop the latch from flickering so fast that it burns it out. And otherwise, let's try it out. And another thing I observed is when I take my finger off, I'm both listening to what's happening to the latch as well as watching what's happening to this light when I do that. And watch the timing of this. Now that was harder to tell. Let's try that one more time. There we go. So let's do it one more time. Finger came off, light started to fade, and the relay clicked. I think it happened in that order. Let's try one more time. Okay, finger definitely came off first. Whether this clicks or this fades first is kind of to be determined. However, the idea here is I took my finger off, the capacitor took over to delay the latch making the click sound. And once this ran out of juice and the latch did click, then this guy would have lit up, but he would have faded very quickly because there was very little charge left in the capacitor, which would have made a complete circuit from here through the capacitor, through this line, through the LED. And I think that that's why this guy ends up kind of doing a little fade real quickly. So he's living off of just the last hair of juice left in this capacitor as it's dwindling. Because yeah, that little fade out. So anyways, that's experiment 8. And assuming my power adapter doesn't catch fire and explode, I will be on to experiment 9 soon. See you then.